a bit of a demo in some implementation details that I think will answer a lot of folks' questions. So so I don't want to spend too much time on status and updates and so forth, but just as a disclaimer, this represents a lot of work in progress, either both shipping and also work in progress with the SPMF. I'll talk about the relationship between DMTF and OCP, but just quick disclaimer on that. So okay, so just background, and I show of hands, I think people know what Redfish is, has heard the word before. So okay, good. So I'll very briefly, the standards body to create the Redfish specification was formed back in September of 2014, and over time has now grown to 22 member companies. This week I've just added Ericsson has joined. I've had couple other large vendors from Asia that are interested in joining as well. We have some other networking people that are also showing interest in joining. So the ranks of the people involved have been growing quite dramatically with the work we're doing now involving the storage management. We've had a lot of storage companies. EMC joined us recently and has been contributing quite a bit of work. So a lot of vendor support behind this, and we have shipping implementations now in the field. So so that's all real good. From a partnership standpoint, we're trying to do this as open and as inclusive as possible. So we have a work register with OCP, so we can have joint meetings. We can discuss amongst ourselves between the two bodies and exchange information and ideas. We've been doing that certainly in the OCP meetings. We also renewed our relationship with UEFI, specifically about doing firmware update and out-of-band support for the UEFI mechanisms for doing that. And as I just mentioned, we were also working with SNIA. They are developing a REST-based interface for storage management, and that is now going to be all based on the Redfish model. So the specification itself, if you're not familiar with it, this is a RESTful interface for doing systems management. It's in JSON form. It uses the normal HTTP verbs for gets and sets. It is a schema-backed data model, and we do that for programmatic support so that applications can consume schema and automatically generate GUI informations and so forth. It's very helpful for implementers to have that schema. For end users, we're trying to make it so that you don't have to read the spec and you don't have to read the schemas. You can look at the payload, and we're trying to make it as human readable as possible to make it very easy for people to write their own curl scripts or their own little utilities to gather information from all the supported platforms and do something interesting with it. So as we go forward, we're going to continue to produce some more white papers and other kind of how-to guides, sample code, and so forth to try to help seed that ecosystem so that you can just pick this up and run with it. So don't be afraid of the schemas. Don't have to read them. We're trying to make it so that you can just look at the payload and go, oh, I know what that is. So the intent of the Redfish spec was to make things easy for the end user to consume. So what Redfish does not do is does not get into the gory details of the architectures behind the interface. So you won't know anything about I2C addresses. We don't talk about device IDs. All this kind of stuff is all hidden behind an abstraction layer that is then put out in plain English text. If you're a program and you need to know that a fan is related to a hard drive versus a CPU, that information is in the model. It's available. If you don't care, you just want to see that all your fans are running, you can do that and don't have to follow all these all this information and know all those architectural gory details that a lot of us in this room have to deal with and kind of love. So it's been driven from a data model on use cases. So we know that if you want to look at temperatures, you probably want to see all the temperatures. So we provide a single array of temp sensor data. So with one IO get, you can get all the temperature data for a particular platform. And it's trying to drive those kinds of use cases as to what are you trying to do with this data? Let's make it easy for you to get that data. And last on this slide, and this is what we're going to get to here, kind of in a little bit of our demo here, is that the intent of the spec at a 1.0 level was to meet all of the requirements of the OCP machine management spec. I'm not going to read this slide again, but this is the 1.0 feature set in terms of what was covered by the specification. I'll pause just for a second so folks want to take a picture of that, but the slides are available, and this is actually just another form of a slide deck that we've had on the DMTF website for quite a while as well. So the important thing I think to pull out there is that from a sensor perspective, everything that was in IPMI that was well understood and well implemented, that's in the spec. If there's something that was in the IPMI spec that wasn't in wide use, or we found somebody that said, yeah, I need that, we didn't put it in. Now, if there's something that we didn't put in that somebody says we want that, it's very easy to add. So we tried not to boil the ocean, tried not to spend years developing every possible permutation of product to put in the spec. It was more important to us to get a minimal model, get it out the door, and let everybody kind of start consuming it. And if we missed something, it was either we didn't get around to it or we didn't think anyone was using it. So it was more the former, less the latter. So the model will grow over time. I think one of the things that one of our customers talked about yesterday was that we had noted that we'd missed, oh, there he is, noted that we had missed the capacity of the hard drive. So that was one of the properties that kind of accidentally fell off. So that got added into the hard drive model, obviously. So kind of an important property for a hard drive. But adding things to the model is a piece of cake. It doesn't break any backward compatibility. We can do it all the time, and we absolutely want to hear that feedback in terms of things that need to be added to the model. So from a release standpoint, we went final on the version 1.0 of the specification back in August of last year. So that has been shipping now for, well, 6-7 months. There are implementations of Redfish in the wild. So you can tell if your vendor isn't supporting it, please go beat on them and tell them that you want it. In the standards body, we've been continuing working on errata versions of the specification, fixing things, clarifying stuff, and that is ongoing. We've got the spec open right now, trying to knock out a second errata release, trying to do some more clarifications. And so if anyone is using the spec, using Redfish, if you're trying to implement, if there's things that don't make sense, you don't understand, not clear, send us email, please, as we'll try to clarify things as much as possible. We want interoperability to work. If we don't make interoperable implementations, then this is not, this was all for naught. So we want to get that clarified, and we want to make it simple as possible. So going forward, you're probably going to see three releases per year of a spec and a schema bundle. All the schemas rev independently, so the system or the hard drive or the chassis, those can all version independently, and as we add features to either one of them or any of them, they'll get thrown into the bundles and get released. So we're not trying to rev everything sequentially. It's not going to be giant bundles of everything new, and if nothing changed, we leave it alone. And that's one of the beauties of having all the version independent pieces. I apologize for going fast, but I'm trying to make sure we have time for some demo talk here, because I know that'll be as interesting to you as anything I'm going to say. So the progress we've made since the last time we were here is other than beyond getting the spec out the door, a lot of new members have joined, and also a huge quantity of new content has been coming into the forum that we're working through as quickly as possible. And we're almost overwhelmed with how much new data has been coming in and requests for models extensions. So this work is all underway. You will see some work in progress documents come out in the next month or two. We have face-to-face conferences every month. We have one in 2 weeks in Houston for a couple of days to try to get a lot of the stuff put together so that we can get them out for review. But in terms of the quantity of things in the data model, PCIe devices, switched PCI fabric pieces are being added. The entire storage subsystem, other than the simple pieces that we had on the model already, that's being added. Support for details of network adapters and obviously a lot more details on networking and switches. That's all under discussion. And as NVDIM and DIM inventory, those things are becoming hot topics, and certainly a kind of a 2016, 2017 product, big product push. That is something also that's going to get into the model. So to that end, that's all the data side. On the spec or the protocol side, actual functionality in the spec, we've got a series of task forces that have been created to kind of get all the like minds to talk and make some progress there. The one that to me is the two highest priorities there are the standardization of a host interface to be able to consume Redfish data from an in-band or from the OS side, and we are working very hard on that to make sure that client software can be built to both work on the local platform or on a remote machine. Try to do that as transparently as possible, make the software as easy and make it easy to build a client that can consume both styles. So that you'll be seeing works in progress, documents, previews of those come out here in the next few months, and hopefully by the end of the year hopefully before then we'll have a final on that. Firmware update, as you've heard this morning, obviously I don't think it's news to anyone that firmware update is a huge pain point for just about everyone. And so what we're doing here, and this is an important point for Redfish, is that we are the interface. We're providing the knobs and the levers to control these things. So we're not going to specify the formats of what a firmware update package looks like. We're not going to do the integrity checks and all the rest of the things that go around this, and version controls and so on and so forth. All we're going to do is provide the levers and perhaps help you to get the bytes from one point to the other. Once they land at the platform, once they land at the BMC or whatever's controlling that process, if that's UEFI or something else, or the PMCI agent that's also been defined, that's all behind the scenes and not part of the spec and not something that we are going to get into. We will support anything that's out there. We're not looking to invent new ways to do things. We want to work and leverage as much as possible. Other things, obviously, I said storage. We have a partnership with SNIA, the Storage Networking Alliance, and they have chosen to adopt the Redfish model for their SSM storage management effort. So that's obviously a huge undertaking, and they've got a lot of folks that are working on that now. Privilege mapping, the last task force that we have is one trying to help improve the security model and the granularity allowed for users to be able to say access some of the data model but not other parts, or read write access to kind of get beyond the basic roles that were available in previous management styles. Trying from an IPMI standpoint, you have kind of the operator, user, and admin levels. We want to allow folks to have more granularity. If you don't want that capability, you don't need to use it, but we want to make sure that folks that are currently using what would be best called poor security practices on their PMCs, we want to give them lots of ability to not do that anymore. So one of the things that we are really interested in working with the OCP groups on are and looking for a term for this. The one we've settled on, at least for the moment, is an integration recipe, and this is what we wanted to show today. Was Paul's stab at this, is trying to take a list of properties out of all the things that are possible in the Redfish model and say, okay, to meet the OCP customer, what things do you have to have? And make a checklist of that to say, okay, if you want an implementation, if you're a VMC provider, if you're a hardware company, or making a top of rack switch or whatever, I want to be managed via Redfish, and I want to meet a certain level of criteria that are put forth by the OCP group. What do I need to have? And so I think, and getting that checklist so that somebody can kind of go on the list and say, yes, I meet the standard, I meet what OCP's requirements are, I'm done. And we want to be able to create that, publish it, and then be able to point to it so that when somebody asks the question, what do I need to support? There's your answer. And obviously there's a lot of other groups that are probably going to want to have those kind of checklists or recipes available, and we're open to publishing any of those that we get. But we think that this audience is clearly the one that is really important to us from getting a good target. I'm running quite. Yep. Just trying to go as quick as I can. On the tool front, and this is the chicken and the egg part of any specification for doing systems management or any network protocol for that matter, is that you've got to produce the client side as well as you have the service side. So we've done a lot of the producer pieces, and that's where our focus has been to make sure that we get the platforms, the long lead items, to get vendors to implement this on the server and the device side. And now it's time for us to start working on the client side. We think that the DMTF can help on this from providing some sample code and some direction, but quite honestly, we don't know exactly how everybody uses this stuff, how they integrate this data into their own tools, their own pipelines of orchestration or deployment and so forth. So we want to basically give everyone the toolbox, or we call it the tackle box. It's a fish thing. We want to give you that set of tools that allow you to build your own things, to be able to consume the redfish data, as easy as possible, get you through a couple of the things that you have to know to get started, and again, provide more educational pieces from white papers and how-tos and so forth. So we're trying to make this as easy as possible, and that has been the goal all along, and we're going to continue to do that on the tool side. The one thing I heard is new is that we did went through the motions, and we've got permission now. We will have an official DMTF GitHub repo where we will be publishing these kind of code samples and snippets and conformance test suites and this kinds of stuff, so that everybody can use them and then leverage them and build on it from there. And if you don't like the code we built, great, go build your own. We'll point to that too. So now on to the interesting piece. Paul from Dell has graciously built a mock-up of a sample implementation of a redfish service, which we affectionately called Catfish. Which do I say the joke? Yeah. Well, we worry about Catfish because it's not a scalable solution. But anyway. Somebody got that, all right. And Paul, I'm gonna turn over to Paul here in a second. Let me come back to just to say where we're at here. We do have a discussion, but I have to take a break here from the previous information we had was all approved by the DMTF and was approved for public release. This is actually a contribution from Dell. I'm fully supportive of it as well from HP side. So. But this is not representative of work from the DMTF at this point. So with that out of the way, we'll talk about the Catfish model. I'm going to back up here and let you kind of get that one.
Can you hear me? Yeah. Okay. So I'm the other co-chair for Redfish with Jeff, and so one thing. I agree with many of you. If you first look at the Redfish spec, it looks kind of complicated because it handles all this extendability things and lots of information that for enterprise maybe not everybody needs the scale out space. So, but all along we made sure that it didn't get too complicated for the simple use cases. So the Catfish mock-up, and really the Catfish is the pragmatic simple fish, right? He's the workhorse of the fish industry in Texas. So. That's the reason we named it Catfish here. So the idea is it was inspired kind of by what the remote machine management spec that OCP worked on a couple years ago had with the features in the remote machine management spec. So this one is one monolithic. There's one chassis there for one BMC, and has real basic management features like power on, power off, next to Pixie, and a few temperature sensors, and very, very simple power reading. You can read the power draw and the power capacity, and some fan monitoring. So this is a subset of what some systems have, but it shows you how simple this would be to implement and consume. So I think when you get it down to a simple system, it's very simple to actually scale and to use. So what it doesn't include is there's no PSUs in this model because the remote machine management spec didn't have PSUs. If you wanted to add them in, it's trivial, right? It doesn't have processor info, memory info, storage info, Ethernet info, which is in the Redfish model right now. Maybe this is something everybody really wants, didn't want 3 years ago. It doesn't have tasks where you can schedule something for something to happen later. It doesn't have a bunch of schema registries where you can, list what schema files your implementation conforms to. It's not required in the model, so we left it out just to be simpler. And it doesn't have an event service. Remote machine management use pet alerts, so it's not clear how we would, you could always still use per pets, right? Okay, so. I'll go through and look. I've got a few screen captures. If we'd had another 30 minutes, we'd have just walked through, manually walked through some of these schemas, and we could actually see it. But what this shows is if you do HTTP GET of the Redfish root service. Usually it's it's actually always IP address /Redfish v1. Okay, so you get this very simple response, and it's actually in any implementation. This could be a completely static page. Implement is all file that you just catted out. It doesn't. There's nothing dynamic and complicated about it, and it points to a link to a collection of systems, a link to a collection of chassis, a link to a collection of managers, an account service where your users are. So this is the standard root service. That's on a monolithic. This is what you have. This is not hard to implement.
Yeah,
and just actually copy this text over and cat it out.
And if we say that there was one part of Redfish that was more complicated than I think folks would have liked, it's this collection at the root cent, because we want to be able to support both monolithic systems, but also implementations where this may be a top of rack aggregator that's showing a dozen nodes. It may be a chassis that has 20 blades inside. So, but by doing the system in this way, we allow for all those things to work with the same code. And so it's not a question of somebody wrote a monolithic tool and then I come by with a blade system and it breaks. And so from the get-go, we want to make sure that we had multi-node, all baked in the model. And so this is the little bit of step that yes, we admit this is a little bit of complexity to get into, but it's a little bit, but the benefit significantly outweighs the little extra bit of code.
Right. So the next response we show is if you read the systems collection. Again, this can be a completely static response on a monolithic. So you do the get, and it'll give you a link to your one system. If this was a 4-node system, it would have an array of 4 nodes. If it's a 48 node system, you'd have 48 links there. Then this is really actually quite common in modern REST APIs that are being used today. So what we've discovered is people that just instantly, this is obvious to the users that are currently using REST APIs, like from OpenStack. There's a few things that you'll see in some of these down here. This is sort of for generic OData clients to use. You could actually ignore them. It's not that complicated, but it's, again, they're all static data, right? It's very neat. One tap, and this just says what the schema tap of this resource is. Again, this is a static file, and by the way, I point out that the single collection of managers and chassis for a monolithic is also this very simple collection of one thing. So it's really simple, not that hard. Okay. So this is now we get something more interesting, right? Now let's do a get of the specific single system that you have in this monolithic, and I've highlighted in red the data that's truly dynamic. A lot of the data, again, could be statically generated. Just do static printfs and so forth. Most of this on the right is structural links to get back to your chassis that you're in, the manager that manages it, the actions you support, like reset and all the different kinds of resets. You know what your system does when you implement it. This is all really static data, right? You don't have to calculate it some way. And but the data you do kind of have to calculate is you have to look up the asset tag, the serial number, the UUID, and so forth. So the red really just shows the data that's dynamic. And so once again, this is not too complicated, I don't think. I think there's a few things you can read back, like to know what to do. Set next boot PXE. What you would do is you would do a patch to set the boot override to once or continuous. You'd set what your oops, what was that?
The wonders of
I thought I had a touch screen there.
I did, yeah. You caused a firmware update just by the touch.
I've done that on my monitor a few times since I got a touch screen. So you can set it. Do you want to go to UEFI mode, or do you want to go to standard BIOS mode? And then what is the next boot PXE? And then this is a property you could read back to say, for this particular system, which boot targets do I support? Right. So again, that's kind of static. So again, most of the data is really static. So for an implementation to support this, it's pretty simple and clear.
Yeah, and you see that, a lot of the stuff that is static, but that's there for either for software to consume to be able to better operate and provide values. That those allowable values array, for instance, is something that you could consume, define, and produce a drop down list in an app to say what these will work on this system. It's not a list of everything that the spec supports, it's what the system supports. So this is a lot of information, it's a lot of extra data to help software consume it. But again, if you're just trying to write a curl script to pull the serial numbers, you can just ignore it.
Yeah,
and it doesn't even get in your way.
Same thing, the OData context ID. These are easy to put in because you can follow a very simple rule to create them when you're doing a service implementation, and a client can ignore them. But they're going to allow the next generation of OData aware clients to automatically parse a lot of this stuff and automatically fill in things. And
so when the Microsoft guys have tell us that by having this information in there, that I will be able to have the Excel spreadsheet kind of live import all this data and produce a report. We kind of said, okay, I think that's worth a property.
And we worked real hard to try to not make it too complicated because it's a pretty simple patterns that we can put in. Okay, so I think we didn't figure out we had time for everything. This is an example of if you do the chassis, so you see a lot of just static links back to the and then a few data you have to fill it. Asset tag. And then I think I threw in the power one. Yeah, power is a good one. So if you want to know how much power you're consuming, okay, so there's a standard power struct under the chassis. It'll tell you, it's this is the watts that you're actually consuming. That's like get power reading, the DCMI, and then the capacity of the power supplies. This is your like a DCMI power limit. If you want to set the limit and what to do if you hit the limit, and so forth. So very much aligned with remote machine learning spec requirements, and simple to write them and simple to read them. So,
and I think as we said earlier, there's some additional structure you see there because that power control is actually an array. So if this was a more complicated system or a larger rack level thing, you can have multiple power controls. So the same thing you'll see in the power supplies as an array. You could have multiple power supplies, the fans, the temperature sensors, all those things are arrays to allow for larger and larger systems and more complicated. So we wanted to show the basics here that so you see a little bit of overhead there from I could have just done this as a simple power thing without the array, but then software compatibility would have meant that that if somebody comes around with a 2 supply system and now the code doesn't work. So we're trying to get this all into the spec from day one.
Right. I think that's pretty much the end of the Catfish thing.
Yeah.
Jeff and I'll be around after 12 out here, and I've got a full live mock-up that runs live with this kind of stuff. Anybody wants to look at it more, we'll post this mock-up too in case anyone wants to look further.
All right, so let me close out just to give you 2 things. Number one is if you want to know more about Redfish and kind of explore the model and the data that's in there, redfish.dmtf.org, there is a live schema explorer, resource explorer. So it actually pulls data from our schema and lets you go, kind of click through the model and, kind of get a little drop down help as far as what does this property do, what kind of things are supported and so forth. So that's a really good way to understand the model and see all the data that can be available. And then so I'll throw up here the feedback and all the, if you have feedback about the spec, we obviously through OCP, we can take this feedback. You can also just submit it directly to the DMTF. The best answer though for providing feedback is coming soon, and I'm working on this as we speak. We're going to get a Redfish user group, an internet-based forum, and then from there we'll be able to post lots of information and have really an open community to talk specifically about this. So with that, we'll take questions. Thank you. No questions? Gotta have a question. Here, we'll see what happens here.
So I'm Rob Lester from HGST. So we've actually spoken on emails a couple of times. So we're coming from a heritage of SCSI enclosure services. Mm-hmm. And so we had a discussion a while back about some of the elements in enclosure services that aren't in Redfish today. Current sensors is, I think, one.
Yep.
SAS expanders, that there's some others as well. Right now, we're on the verge of producing a product in the wild that will have Redfish in it. Cool. We're putting everything into vendor unique.
Sure.
Are those kinds of things being addressed?
Great question. I got some fish food for you. Those are redfish, by the way.
They are.
So the answer is great. The things you mentioned have not been the SAS expander stuff. The storage guys are going crazy trying to figure everything out, and we're trying to beat the easy into them. There's a giant fish joke there too, but in terms of things like what was the sensor type?
A current sensor.
Current
would be
sensor.
an example.
So again, we implemented and trying to get one out the door. So we just did what we knew was commonly implemented, kind of in the server space, common IPMI kind of stuff. So current sensor was certainly, that's a very common. I mean, it's certainly we can define that from an industry standard standpoint. It's pretty much amps and what does it do, right?
Exactly.
So please bring a proposal in, or just send it to us and say this is what we need, and we'll add it. It's a piece of cake to add, and we can rev those things. Literally, it takes us about 45 days to get from a proposal that we all okay, it looks good, to having it as a published, validated, verified, or approved industry standard. So for things like humidity sensors, there were lots of things like that we just haven't gotten to yet. But if somebody wants it, then yes, let's move that out of OEM space into the standard so we get interoperability. Thanks.
By the way, I'm happy to share fish because I don't really want to eat this much fish.
I got more fish. Sir.
When does redfish and DCIM hit? Is the kind of overlap with the redfish infrastructure? Where's the boundary?
Great question. Almost got there. So the question was, where does redfish end and where does DCIM start? And the answer is I'm not sure. I think there's some dynamic, there's some boundary there that I think we need to figure out. But I think in general what we've done from redfish is really an element, kind of that leaf node of thing. I don't expect things like orchestration, whatever you mean by that, in terms of like I'm trying to balance things or control software, probably doesn't fit the model of what we're trying to do. So I think we're mostly trying to expose raw data and then allowing you decision support systems above to be able to control those knobs and levers. So, but to that end, where's my folks from Emerson? There got to be something that we've got infrastructure folks that do lots of rack and power and stuff. Oh, there we go. That are involved in redfish and have been since day one. So we absolutely want anything that's in the data center, that has power to it. We want to have that with a redfish interface on it, so you can control it. And then where that leads, beyond the rack, the power, the crack units, and so forth. When we get beyond that, at the upper layers, probably not a redfish topic, but if it makes sense, it does. If it doesn't, we want to make the data available. Other questions?